In this video we will be having a look at the electronics that was of two types, the digital and the analog. So analog electron wait yes so the digital and the analog. So first of all, I'll tell you about the analog electronics. We'll be discussing first about the analog electronics. Analog electronic. So analog electronics have the it have the continuous and the various quantities. How, like, it have the varying quantity. Varying means changing quantity. It have what? It have the varying quantity. For example, thermometer. Sometimes thermometer is high and sometimes the thermometer is low. So this is what? This is the analog quantity. Okay. And if I would give you the example of your mic or your amplifier, what amplifier do? It provided you the voice. It increases sometimes the voice and sometimes decreases the voice. So here, as you can see, that the quantity of the sound and is varying, means it is changing. So that is why analog provide always what? It provide the varying quantity. Another example for that is temperature. Temperature is sometime increasing and sometime decreasing. So this is also what? This is also the example of the analog temperature. Another example for the analog would be our radio. Sometimes the radio is high and sometimes the speed or the voice of the radio is low. So as you can see that there are many type of analog quantities or the electronics, and on the other hand we have also the digital electronics. So moving towards another point, we have discussed number first. Now I'll be discussing number second. That is, analog signal are in the form of waves. They are in the form of what? They are in the form of waves. Okay, because as we know that it is a varying quantity, so it always be in the form of wave, sometime increasing and sometime decreasing. As you can see, it is increasing, now it is decreasing, increasing, sometime decreasing, increasing, decreasing. So this quantity, this is known as the varying quantity, that is our wave. And this wave of the analog is known as sine wave. Which wave? This waveform is known as sine wave. Okay, because as it is sometime increasing, let me tell you, sine wave first of all. So as you can see here, it is increasing. At this point it is increasing, okay, but at this point it is decreasing, increasing, decreasing, increasing, decreasing. So as it is a varying quantity, means analog electronics are the varying quantity, so it is changing its form. Okay, so next point we have, let me write over here, that it do not store the data. What? It do not store the data means analog electronics are not more accurate as compared to the digital electronics. So here, why comes the point of the accuracy? When the point comes of the accuracy, so always remind your mind that the device that will have the least count less, they will have the more accuracy. For example, why it cannot store data? It cannot store data. Why it cannot store data? Because analog electronics have the least count less than digital electronics. Means analog electronics have less least count, but digital electronics have high least count. So that is why it cannot store data. If we talk about the least count, so the least count of analog electronics is 0.1 second. Analog stopwatch, I'm giving the example over here. Analog stopwatch, the least count. Now on the other hand, the least count of a digital stopwatch is 0.01. So who have the less one? Obviously the digital one. So it will have the more accuracy. So that is why the analog electronics cannot store the data. Next up we have that now we have that the analog signals are very much affected by the noise, means the unwanted fluctuation. It very much responds to the unwanted fluctuation. It responds to the unwanted fluctuation, means the fluctuations are coming in the device, it responds very rapidly, it give a unwanted response, we can say that. I will repeat my statement as well. You can write that analog signals are very much affected by the noise, means it gives the response to the unwanted fluctuation, unwanted voltage fluctuation that are not necessary. Respond. Now I am giving you the example how it responds to the fluctuation, unwanted fluctuation. If we move a voltmeter, we know that okay, let me clear that term, that analog electronics give us is more like, if I could tell you, for example, the watch at your home, the watch that are you currently using at your home, it is in this shape. So that is what, that is also the analog, because it gives you the accurate, like it tells you the seconds, it tells you the time, it tells you everything. So that your watch is also what your watch at the home, this watches are also the digital analog electronics. Okay, so now the fluctuations are coming into your this for example, this watch, so it give response very rapidly. Okay, now I am going towards our what do we say, yes, digital electronics. I hope that is clear. Okay, now I'm moving towards our digital electronics. Let me write digital, sorry. So digital electronics is like, of course, we are doing here the comparison. So digital electronics must be the opposite of it. So digital electronics are the measure discrete as well as continuous varying quantities. How? Like it can separate. Discrete means separate. It can measure the discrete quantities as well. For example, our computer, like it have sometime have the discrete quantities. For example, if I would give you here again the example of the temperature, here again the temperature example, let me write first point. So here I am giving you the example of the temperature. For example, temperature is changing every hour, so sometime it give you the accuracy, but sometime it give you the discrete, means separate. At this hour the temperature is this, at this hour the temperature is this. So yes, this is the digital electronics. Okay, digital electronics are like your computer and your laptop screen, because when you're charging your, for example, your laptop is not charged, so it give you 0%. Okay, but when your laptop is charged, so it's give you what, it give you 1%, that shows 1%. So this is what, this is the varying and discrete quality, sorry, quantity. Discrete plus continuous. And other example can be your chips in the ID card, your sensors. Sometime it tells you correct, sometime it tells you the change. So that is why these are called the digital quantities. Now we are, let me write the example. Example can be computer and laptop, sensors, chips, temperature every hour. So that is why we all measure that in our digital electronics. Now moving towards our second one, that digital electronics are in the form of 0 and 1. What? They are in the form of binary numbers. As I told you that the analog electronics were in the form of wave, they are also in the form of waves, but they are in the form of what? They are in the form of binary numbers. And binary numbers in the Boolean algebraic is 0 and 1. Okay, means it is a algebra, it is like the common rule that binary number is what, 0 and 1. So digital gives you the binary numbers, it gives you the it provide you the data in sometime minimum. It provide you the, like 0 means minimum. Okay, it provide you sometime the minimum accuracy, sometime the maximum. So maximum here is 1 is used for the maximum. Okay, so they are in the form of what? They are in the form of binary, plus they make the two levels of wave, that is in the form of square wave. What they make? They make this square wave, like they are in the form of this. Okay, and one thing, that they are more accurate than this. Okay, more accurate, because it have the least count of 0.01 second. Okay, more accurate, because have what? Because it have the least count is, I am writing that LC, least count is 0.01 second, as compared to that analog. Okay, it have the least count of this. Now moving towards our another point, that is it stores data. How it stores data? Because it have the least count more than that, so it stores data. As well. Digital electronic stores data. For example, our CDs is a good example of digital electronic. For example, our CD. Okay, now moving towards another one, Next up, we have that digital signals are mostly not affected by the noise. For example, they are not they break like they do not respond to the unwanted fluctuation. Do not respond to the unwanted fluctuation. Okay, so this was the difference between the analog. So in our homes we are using the analog one that provide do not provide us more accuracy, but it like give us the times in seconds and these all. But talking about the digital one, so like sometimes tell you the seconds and sometimes tell you what. So that is why, like, the more if we talk about the more accurate one, so I guess the analog is like the more accurate one. Yes, sorry to say digital is not the accurate, but analog is more accurate, because as you can see in your homes there is like the watch that is based on your wall is in this shape. Let me like this one. Okay, so it provided more seconds and these all. Now we're talking about the digital one that is in our phones. It tells you only the minutes. If I could, like, for example, analog when if I talk about that, our voltmeter is also okay. And I am making here the digital. Okay, I hope you might have seen on the airports and like these areas the digital watches are almost being used over there. So there this like more accuracy is not given there. So that is why I hope that is clear.